Hello and welcome to this lesson on properties of ionic compounds. Last time round we talked about ionic lattices and we talked about how to write formula of ionic compounds. In this lesson what we're going to talk about is the properties of ionic compounds. The properties we're interested in are the melting and boiling points and the electrical conductivity of ionic compounds when they're in different states. So to start off, before we even do any of that, we're just going to remind ourselves of what an ionic bond is. The reason for this is this definition will help us with this lesson. So, I'm sure you're sat there thinking, right, let's get it. Revise that mantra. What's it going to be? That ionic bond, what is it? Okay, it is a strong force of electrostatic attraction between oppositely charged ions. Strong force of electrostatic attraction between oppositely charged ions. So how is this useful in helping us with the properties of ionic compounds? Well, actually it's just a couple of key words within this definition. So the first property we're going to look at is melting point and boiling point, and the word we're interested in here is strong. Now there are all sorts of forces of attraction between atoms, between particles, molecules and compounds, and they can be of all sorts of different varying strengths. Now when we think about an ionic bond between those ions is very, very strong. So if I was to look at some solid salt, like I've got here, so think back to the last video, we talked about solid sodium chloride, and it's in this wonderful ionic lattice structure when it's a solid. The force that is holding these ions together is really, really strong. So what does that mean in terms of melting point and boiling point? Well, if I wanted to turn this solid into a liquid, I would have to use an awful lot of heat in order to do so. What that means is it means that ionic compounds have high melting points and boiling points. What's our explanation for this? Well, all we need to simply say is they have high melting points and boiling points because lots of energy needed to overcome the strong ionic bonds. Okay, and I can put on, to make it even better there, between ions. Okay, so that's the first property already talked about. Okay, what kind of melting point and boiling point do ionic compounds have? They have really high melting points and boiling points. So what about the second property, electrical conductivity? Now, electrical conductivity is an interesting one, and it's a property that you get asked about with all the different kinds of bonding that you will learn about at GCSE. So what the key thing here is, we've got to think about these oppositely charged ions. Now, the word charged, okay, might make you think, okay, well, there must be some ability to conduct electricity, and you would be right. However, there are two conditions that need to be met, okay, before something can conduct electricity. The first is you've got to have a charged particle. Now, why do you need a charged particle? Well, you need that charged particle to carry the electronic charge. What's number two? Well, the second thing is that those charged particles have to be able to move. Now, if we think about our solid, okay, so we're going to start here with the solid. We've got these ions. These ions are in this regular arrangement whereby they've got those strong ionic bonds holding them together. Do you think they can move in this scenario? No, they can't move. So when we think about the electrical conductivity, here in a solid, it can't conduct electricity. If you had solid salt, a little dish of solid salt, trying to put a charge through it, nothing would happen. However, when we then say dissolve our salt in water, so what we've got now is this is some water, so it's in a solution, so we call this aqueous. What can suddenly happen is our ions are free to move. So in this state, okay, the ions can actually move and carry some form of charge. So when we think about things in what we call an aqueous state, they can conduct electricity. And the reason they can conduct electricity is because there are free moving charged particles. And in this case, those charged particles are ions. So the last scenario in which it could conduct electricity, okay, is if you had a liquid. So this is sort of just using a little bit of particle sort of drawings. This is no longer a lattice. Things are a little bit more irregular, but these particles are able to move and therefore conduct electricity. So here we've got a liquid, and here too they are able to conduct electricity. Okay, so we've got it's able to conduct electricity in aqueous and liquid states. Okay, liquid states is also referred to as molten. And the reason for that is because in order to turn a salt into a liquid, you have to heat it an awful lot, but it cannot conduct in a solid. So how do we answer this if it comes up as a question? Okay, well, let's have a think about this. An ionic compound cannot conduct electricity when solid because the ions cannot move. Okay, so ionic compounds cannot conduct electricity when solid because the ions cannot move. So we can go on to say that when ionic compounds are molten or in an aqueous solution, they can conduct electricity because the ions are free to move. So what you're looking at there is you're looking at a generic answer to the kind of question that you might get referring to the electrical conductivity of ionic compounds. So they can conduct when they are molten or aqueous, but they cannot when they are solid, and the reason because of that is to do with how the ions can move. So this little model of the fact of the charged particle being present and the charged particles being able to move sort of give that framework and structure to our answer. Now whilst we're here, I'm just going to introduce two more words. If we were to think about our water and our aqueous solution, how is it that we'd actually test to see if an electrical charge would go through them? Well, what we would do is we would put in, some electrodes. Now, these electrodes could be made out of all sorts of materials, but what they would essentially be made out of is probably the first time you do this, they might be made out of carbon. Certainly if you were to do this in the chemistry lab, they would be carbon electrodes. Now, these two electrodes have names, and they have quite specific names. And this is a good opportunity for us to recap a couple of the names of our particles. So back here in our little model, I said that this was chlorine, which is Cl- because it's a chloride ion. And I said that this one here was sodium, so this is Na+. So what we've got is we've got our positive ions, which we also called our cations, going to our electrode on this side. So we've got the cations in purple. So what we call this electrode here is we call this the cathode. Over on the other side, we have our chloride ions, which are the negative ones, and we call them anions. You can remember that from the last video. And what we call the electrode that they go to here, this is called the anode. Just a good opportunity to introduce a couple more chemistry terms. How do you remember those two terms? Well, nice easy way, do not panic. Well, why don't panic? Positive is anode, negative is cathode. Positive is anode, negative is cathode. So, in summary, what we've talked about in this lesson is we've talked about our definition of an ionic bond and how we can use that to describe and explain the properties of ionic compounds. So we've looked at melting point and boiling point. We've discussed the fact that they are really high, and the reason being for that is because lots of energy is required to overcome those strong bonds, strong ionic bonds between the ions. We've also then talked about the electrical conductivity, so talking about the role of those charged particles. In order for a substance to conduct electricity, first off, it needs to have charged particles. Secondly, those charged particles need to be able to move. So when we look at an ionic compound, it can conduct electricity only when it's in an aqueous solution or in a molten state, because there the ions are free to move, whereas in a solid the ions cannot move because they are in that lattice structure. So hopefully that sort of capped off all of the information for ionic compounds. What we're going to look at in the next set of videos is we're going to talk about covalent bonding, which is slightly different. Then we'll talk about metallic bonding, and then we'll compare all of our different compounds. And then you're going to try and figure out, when I give you some data, what kind of compounds those things are. Okay, so thank you very much for watching. Please like the video, subscribe to the channel if you haven't already. Your support is greatly appreciated. And as always, I will catch you in the next video.